Hello, everyone. And thank you for inviting me, or actually my student, that popped up. My student, Karen Engelbrecht, prepared this presentation, but then after MSc, she got a job and ran away. So I'm presenting this for her. And she specifically looked at the PSHB beetle and its fungus and its effects on deciduous fruit trees, or susceptibility. Most of you, all of you know that the PSHB has invaded in the country since 2012, very wide host range, anything from urban trees to natural forests. And for the first in the world, it's also started going into deciduous fruit trees here in South Africa, in Somerset West area, probably also in Stellenbosch. And the danger of this is unknown. It's a world first, so we have to have a look at this. So the objectives of her study was to look at the pathogenicity of the fungus, the symbiotic fungus, to deciduous fruit trees, to look at the colonization success of the beetle on these trees, and then see if there's a link in host susceptibility and the preference for the beetle for certain things. Do the beetle actually choose different trees or not? Which turned out to be more difficult than we thought. So a thesis had two chapters. The first one was just a really initial survey on what's going on in a pear orchard, because this was the first sort of time that it went into pears in an orchard, which was published recently. And in this study, or in this chapter, she did some initial monitoring on pear, one apple, two plum varieties, and then also some grapevines in there. Made sure that it is PSHB and the fungus in these trees, so identified it, and then did some initial pathogenicity trials with the fungus on pear. So quickly going through the results there for the monitoring. So PSHB infestations were found on all, I see the pear disappeared there, so on pear, plum, grapevine, and apple. Although on grapevine it doesn't seem to be a problem at all. Then she identified the fungus as Fusarium euwallaceae and the beetle as PSHB. And the fungus is a pathogen. Sorry, this thing is automatically skipping for some reason. It is a pathogen to the pear trees, as shown in that graph. So in the second, I can skip that. So in the second chapter, the aims were to determine the host preference of PSHB to a bunch of varieties of plums and two pear varieties, and then beefwood, which is a known host for the beetle, to assess the pathogenicity of Fusarium euwallaceae of these two Fusarium euwallaceae, sorry, and to see if there's a link between pathogenicity and the beetles attacking these trees and preferences. So in terms of materials and methods for this chapter, did lots of surveys. There's a whole bunch of cultivars there, so each one of those were in a different orchard, so many orchards, thousands of trees that the poor student had to count little holes on. And just literally looking at the numbers of the holes on these trees. Did some pathogenicity trials also on all of those, so inoculating the fungus in the trees. And then, this thing skips too many times. And then for the beetles, looking at their preferences, she did some no-choice experiments, so you don't give the beetle a choice of a food, or some choice experiments where actually the beetles can choose between different food types. So the no-choice experiments we can do in the field by putting the beetles on specific trees using 3D printed traps, and then also doubled that in the laboratory where we place the beetles with the host tree branches in a bucket and let the beetles do their thing. For the choice experiments, that we can do also in the buckets by adding a branch of each host that we tested in the bucket, added 20 beetles to that bucket, and let the beetles choose. And after about a month or so, see which host they preferred or not. So don't worry about the stats there. So results in terms of the field monitoring, every single orchard that she had a look at had infestations. Some had sort of much higher infestation levels than others. For the Packham's pears, for instance, about 40% of the trees there had infestations. Most of them around about 20% of the trees currently. And this is only after 3 years of initial finding this in these trees and in these orchards. And the beetles can breed in all of these hosts. but in very, very low numbers, it seems, currently. The windbreak trees are heavily infested, or the trees surrounding these orchards. Highest infestations were in Packham Triumph pears, and the lowest we found in the black pearl plums. If you look at this graph, you look at the distribution there, you can see that in general, infestations were low for all of the cultivars and species tested. So the first one there, PT, is Packham's Triumph, EBC is another pear variety, and then it's a bunch of plum varieties. And you see a lot of outliers on these, a lot of dots above these graphs. And those trees tend to be the ones that are on the edges of the orchards. So from these results, it looks like the beetles are coming in from the edges, mostly from the windbreak trees and other trees, and starting to infest the trees on the outside. They're not really breeding in high numbers in the orchards themselves. Pathogenicity trials, the fungus is a pathogen on every single thing that we've tested. Some things a little bit better than on other hosts, but in general, it's not really a very strong pathogen, but it does do the job there. So the longest lesion lengths there were on African Delight, Songold, and Black Pearl plum cultivars. Interestingly enough, if you look at, when we go back, to the beefwood trees, which are known breeding hosts, the lesion lengths are actually very short on there. So initially, or immediately, you can see there doesn't seem to be a correlation between how well the fungi is doing and how well the beetle is doing in the tree. So don't worry about the graphs at the bottom there. I can send those on to those who are really interested. In terms of the beetle no-choice experiments in the field, not a single beetle that we put on the trees actually successfully made a colony. And we're not sure why that is. There could be some environmental reasons for that. There might have been some chemical spray that we were not told about. So we'll have probably redo some of those. In the bucket experiments, if the beetles, if you don't give them a choice, they go for pretty much everything at low numbers. So they try their luck on everything. In the second little graph at the bottom there, that's where sort of colonies were actually not established, but galleries were established. So on a few of those hosts, they made galleries, but they were only able to breed in one of the pear varieties, not a single one of the other hosts that we tried. They were able to establish viable colonies. And when you start giving them choices, you see that they start choosing the pear, the apple, and one or two of the plum varieties. And they actually avoid their known host, the beefwood, on the edges. But again, they can establish short galleries in most of these, but only viable colonies in that EBC pear variety, which is unfortunately one of the pears we didn't focus a lot of attention on in the field. So we'd love to see what's happening there. So in conclusion, PSHB in the pear orchards, they literally go for everything when they're in high numbers. They don't seem to really have a preference, so they seem to find their hosts at random and probably by visual cues and not chemical cues. It doesn't seem to be a massive problem at the moment, even though many trees and varieties are attacked. They don't establish viable or readily establish viable colonies in these. But we don't know what's going to happen with all of these holes in the trees, the secondary infections and infestations and things like that. And unfortunately, trying to predict the host status in the laboratory and not on a living tree seems to be a very difficult thing to do because they don't really choose anything in our lab experiments. Yeah, thank you.